Let's find all the values of x such that the given series would converge, sum from n equals 1 to infinity, n+9 times x to the nth. So let's use a ratio test. Limit as n approaches infinity of the n plus first term. So we're going to plug in n+1 in for n. We have n+10 times x to the n plus first over n+9 times x to the nth. And we're going to look at the absolute value of this. We're going to simplify. X to the n plus first over x to the n is just x. And this x is inside the absolute value, so we'll bring it outside because it does not depend on n. And now we can remove the absolute values, and we'll see that this limit goes to 1. So the absolute value of x times 1 is absolute value of x, and the ratio test converges if the limit is less than 1. So our goal is to solve for x. So x is going to be between -1 and 1. The last step is to test the endpoints. So if we test the endpoints when x is -1, we have the sum from n equals 1 to infinity, n+9 times -1 to the nth power. If we take the limit of this, the limit goes to positive and negative infinity, oscillating, so it diverges. And then if x equals 1, we have n equals 1 to infinity, n+9 times 1 to the nth power. 1 to the nth is just 1, and then this limit goes to infinity, so that diverges as well. So x has to be between -1 and 1, or in other words, like this.